So today our topic is Advanced Mathematics Lecture 8, and we are going to talk about basic integral calculus and substitution rule, and also we are going to talk about the previous homeworks. Okay, like the homework of from
Is it just
lecture
started?
7. Yeah, just
Homework?
start. Yeah, just started. Don't worry.
Oh. Sure.
Bukhochi. So previously we had some homework like you can see here 1, 2, 3. So I can start from number 1, and here is the question. So number 1, our question is, suppose that y equal to f of x is continuous at every point of 0, 1 and differentiable at every point of its interior 0, 1. So this part here, it is a closed interval, and this part here, this is the open interval. Okay, if f of 1 equals 0, then there is at least one number c in 0, 1 such that f of c plus c f derivative c is equal to 0. So this means this is very simple, like for example, this is a graph. So our function is y equal to f of x. That means if x is 1, y will be also 1. If x is 2, y will be also 2, right? So our point is like here, like this way, and function is increasing this way. Okay, so and this function will go through the from 0, 0 point. Okay, from 0, 0 point. I need to increase the thickness. Okay, so this function look like this. Okay, and we have to prove that f of c plus c f derivative c is equal to 0. So we have to use Rolle's theory. You see here, hint is Rolle's theory. So Rolle's theory is, we have to consider 3 things. Number 1, this function is continuous in 0, 1 point, and this function is differentiable in 0, 1 open interval. So this function is continuous in 0, 1 closed interval, and this function is differentiable at 0, 1 open interval. So this means, for example, we have, let me change the color. So we have on here, right? This is 1, and also y is equal to 1 here, right? Okay. So this we are considering only this part, because from between this part, so in our question the interval is from 0 to 1, right? So we are considering this part. So in this part, the line is a straight line, right? So it has no hole. Hole means, suppose I am drawing a line, but here is a hole. Okay, you can see here is a hole. So we do not have any hole in this function, and also this function is not a spike. You know, this is like a knife, right? And this part here, it is very sharp. So we don't have any sharpness in this function. If the function is this way, so it has no sharpness. That means it is continuous. But if this function is like this way, here you can see a sharpness. So this function is not continuous. So by looking at the graph, you can determine if it is continuous or not. Okay, just see if there is any hole or not, and if the function is if there is any point that is sharp or not. Okay, so 2 things. Number 1 is there is no hole, and number 2 is no sharp point. Okay, no sharpness. So that means, let's come back here. So these 2 things means this function is continuous, and this function is differentiable at 0, 1. Okay, guys. And number 3 is f of 0 is equal to f of 1. That means endpoint values are same. Like our here our interval is 0, 1, right? So f of 0, this is our endpoint value, and f of 1, this is also our another endpoint value. So these two will be same in Rowe's theory. Okay, Rowe's theory. So if this function satisfies these three conditions, then we can say that this is the formula. So we can say that there will be a point C. That means between inside of this 0, 1 interval, for example, here is a point C. Okay, here is a point C. So that means there will be a point C in 0, 1 that satisfies if f derivative C is equal to 0. And in that point, the derivative value will be 0. Okay, this is the Rowe's theory. So now we are writing down the solution. So let our function, let f of x is equal to x into f of x, and this function is continuous at 0, 1, and this function is also differentiable at 0, 1. And now we find the endpoint value. So f of 0. So just put 0 here. Okay, just put 0 here. So it will be 0 multiply f of x. That means 0. And now put on here. So it will be on into. So here will be a derivative sign. I didn't wrote this by mistake. Okay. So here will be a derivative sign. So if I put on here, so it will be on into f derivative 1, right? And we know that derivative of a constant function, this is 0, right? So it will be on into on multiply 0. Ultimately, the answer is 0. Okay. So that's why f of on is also 0. So by mistake, I didn't wrote derivative sign here. Okay. Also here. So we can see that the left hand limit and right hand limit, they both are same. And so from the Rowe's theory, we can say there exists at least one point C in 0, 1 open interval that satisfies f derivative C equal to 0. Okay.
Omar, can you explain about f or f1? We have to prove both of them, 0 and 1.
Yes, these two are our endpoint value, and I just discussed here. You can see our theory condition. So from Rowe's theory, the third condition is the endpoint value will be same. Okay, endpoint value will be same. So here, where do we find our endpoint value? So you see, look at the interval. We have 0 and 1, right?
Yes.
So if we calculate f of 0 and f of 1, so that will be our endpoint value. That's why we calculate f of 0 and f of 1. Okay.
Okay, we have to write both of them.
Yes, right. We have to write both of them. Then you just substitute x here, okay, and then you get the answer 0 and 0. So this is the answer of number 1 question. Now let's go to number 2. So number 2, we have a function that is x cube plus 3x square minus 9x plus 14, right? And we have to find all the critical points of this function. And we have to identify the intervals on which the function is up and down, right? And find the local and absolute extreme values of that function. Okay. So number 1, find all the critical points of f of x. So we know that the critical points are in f derivative is equal to 0. So derivative of x is equal to 0. Derivative of x is equal to 0. Or this is number 1. And critical point can be also found in derivative of x is undefined. Okay. And number 3, the in point value. Okay, the in point value. So now we can test the first one. Derivative of that function will be 0. So we firstly we firstly calculate the derivative of that function. So this is 3x squared minus 6x minus 4. So guys, very simple. X cube. So x cube will be derivative of x cube. X cube will be 3x squared, right? And derivative of 3x squared will be 6x. So do you know how to calculate derivative of these things? And
Yes, got it.
yeah. So derivative of minus 9x, it will be minus 9. And derivative of 14 will be 0. So because that is a
0.
constant function. So we get 3x squared plus 6x minus 9. 3x squared plus 6x minus 4. It will be minus 4. Why minus 4? 3x squared plus 6x minus 6x.
Maybe you have got mistake to write.
Okay, let me see again. Oh, sorry. This is the final exam of December 13th. So, oh, no, not this one. So, this one here, okay? Here.
Okay.
So, this is the answers. So, we have f of x is equal to x cube minus 3x squared minus 9x plus 14. Yeah. So now let's find the derivative. It will be 3x squared minus 6x minus 9, right? And we know that critical points can be found at this derivative of that function will be 0. So this is the derivative, and we write this is equal to 0, and then we can just take these 3 as common. So we get x squared minus 2x minus 3 is equal to 0. So now we have to break the middle term. Okay, so here our middle term is minus 2x. So if we break down it, it will become minus 3x plus 6. Okay, and then from this two function, we can just take x common. So it will be x minus 3, and from these two we can just take plus 1 common. It will be x minus 3. So x minus 3 into x plus 3. So we can write down like x minus 3 equals 0 or x plus 1 equals 0. So x will be 3 or x will be minus 1. So now we just try to, we got 2 points. One is 3 and one is minus 1. So now we have to put this value here in the main function. Okay, in the main function here. So if we put this value, these two critical value here, these two critical point here. So already I found the answer of number 1 question. Okay, it was we need to find the critical points. Okay, so we already found the critical points. One is 3 and another one is minus 1. So guys, can you see finding critical points are not very difficult task, right? Just you need to find the derivative, and you need to write that the derivative of that function is 0. Okay. So Julian and Farin, Rajiv, Do you understand?
Yes.
Okay. So this was the answer of number 2. So inside of 2 we have 3 questions like 2.2 on 2 and 3, right? So now we have to identify the interval on which the function is increasing and decreasing. So if I draw the graph, like how to draw the graph, firstly just put this two critical point value in the main function. Okay, in the main function. So then you will find that if you put -1, then you will get -19, and if you put 3, you will get -13. Okay, this is the graph of x cube minus 3x square minus 9x plus 14. So
Is it
now
compulsory to write graph, brother?
no, it's not compulsory. I just draw here to make the whole thing more clear. Okay.
Got it.
Yeah. So we got 2 points. One is 3 and another one is -1. So if I write down here -1 and 3, so you can also see like previous one, this is divided into 3 parts, right? Sorry, 5 parts. Here is 3 and another 2 is -1 and 3, right? So here it divided
Yes.
into 5 parts. Number on, this and this part, also this part and this part, right? 5 part.
Yeah.
This 0 is nothing. I just wrote it just like a symbol, okay? Like a signal. So our intervals are from -infinity to -1, then -1, then from -1 to 3, then 3 and 3 plus 3 into plus infinity. Then we find the derivative value. I already told you, right? Just you can just take any number in between this interval. So for example, I took -2. Okay, so f derivative -2 is equal to 15. You just put -2 here. Okay, so it will be 3 multiply 4, that means 12 minus 12 minus 6 into 2, that means 12, and that is plus 12. Okay, minus and minus, that means plus 12, and -9, so it will be plus 15. Okay, and f derivative -1, this is 0, f derivative 2 is -9, f derivative 3 is 0, and f derivative 4 is 15. So you can see this function and this function, these two intervals is increasing, and this is minus, that means it is decreasing. And our local, so how do we find the local absolute value? Like in the question 3, we have find the local and absolute extreme values of f of x. So we have already found it. If you look very closely, you can see that this point here, and this point here, these 2 points are our local extreme point, right? This point here and this point here, these 2 points are our local extreme point. So we can just write here like this is our local extreme maximum, and this is our local minimum. Okay, so the increasing intervals are from -infinity to -1 and 3 plus infinity, because they are positive, and the decreasing intervals are -1, 3, because they are negative. You see here, they are negative. So this way we solve number 2, and for number 3, so you don't need to write this part. Okay, I just wrote this just for example, nothing complex. So again, we calculate like the same thing as I did before, and we get we get our extreme values. One number one is f of 3 is equal to minus 13, and another one is f of minus 1 is equal to 19. Okay, we already found it here, local maximum and local minimum. Okay, guys. So this is like we saw it in the graph, but how do we find it mathematically? So it is very simple. So this we previously we got our critical points. That is, one is 3 and another one is minus 1, right? So we found f of 3 and f of minus 1. We calculate f of 3 and f of minus 1. So f of 3 is equal to minus 13, and f of minus 1 is equal to 19, right? So you can see minus 13 and minus 13 and plus 19. Okay, so we have got the lowest number here, that is minus 13, and our highest number, that is 19. So we can say that f of 3 is equal to minus 13. This is our global minimum, maybe. Yeah, 3 comma minus 13, global minimum or maximum, 3 minus 13. You can see this is our global minimum, right? Because this point is below. This point is below from this point. So this is our this is our local minimum. This is our local minimum, okay? And this point here, this is our local maximum. Local minimum, and this is our local maximum. Because you see the number here. One is minus 13 and another one is 19. So this is global this is local minimum, and this is local maximum. So again, you see, if you look at the graph, so it will ever increase. Okay, it will go upward and upward. So so here the local extreme points and the global extreme points both are same. That means this is local maximum, and also this is our global maximum. Okay, global maximum. And this point here, this is our local minimum, and also this is our global minimum. Okay, so guys, do you understand? Julian, Farin, Rajiv, do you understand?
Yes. Yes.
You can ask me a question anytime, because I'm not your teacher, I'm just your friend. So we will start the meeting again, because it is just 1 minute left. Okay.
Okay.